Okay, so in part C, we're asked to use the ratio test to find the interval of convergence for the Taylor series that we found in part B, which is listed above there. If you recall, the ratio test looks for the limit as n goes to infinity of the absolute value of the n plus first term over the nth term. So in this case, the n plus first term would be x minus 1 to the 2n plus 2. So if the general term was x minus 1 to the 2n, we're going to replace n with n plus 1. And so you have to remember to multiply or to distribute the 2 by the whole n plus 1. And so we get 2n plus 2. In the denominator, we had n plus 1 already. And now we're going to replace n with n plus 1. And now we get n plus 1 plus 1, which is n plus 2 in the denominator. Now I really want to divide the n plus first term by the nth term, but there's so much writing going on in there. And eventually I'm going to have a fraction divided by a fraction. So what I want to do instead on my first shot through is to just write it as the numerator multiplied by the reciprocal of the denominator. And so the denominator, the nth term, was just x minus 1 to the 2n over n plus 1 factorial, and I'm going to write the reciprocal of that. And so I end up with multiplication of these two fractions here. And again, it is the absolute value of that. And what I can do here, first of all, is I can collect my n plus 1 factorials. And since n is always a positive number, there's no need for the absolute values in that place. And my x's then, I would have x minus 1 quantity to the 2n plus 2 divided by x minus 1 to the 2n. And now I can simplify each of those. N plus 1 factorial over n plus 2 factorial. That's kind of like saying if n were 3, n plus 1 would be 4 factorial, n plus 2 would be 5 factorial. So 4 factorial over 5 factorial, since 5 factorial includes 4 factorial times 5, that's going to just be n plus 2 in the denominator. So I'll just take a minute to go over this point, and I'll only do it this one time here. But if n is equal to 3, so n plus 1 is 4, n plus 2 is 5. And so n plus 1 factorial over n plus 2 factorial would be like 4 factorial over 5 factorial. And you do notice that 5 factorial includes 4 factorial. Or 5 factorial, we can say, is 5 times 4 factorial. And those 4 factorials will cancel, and we'll end up with just 1/5. And 5 being n plus 2, so in this case it would be 1 over n plus 2. And so I'll leave that there for a second, but I'm going to erase that red handwriting in just a minute. So back to the problem, we're going to start off with the limit as n goes to infinity. We've simplified the n plus 1 factorial over n plus 2 factorial to just be 1 over n plus 2. Similarly, with the x's, if n were 3, then 2n plus 2 would be 8. And if n were 3, 2n would be 6. And so when we divide two numbers with the same base, we subtract their exponents. So 8 minus 6 would be 2. Whatever n is, the numerator is always going to be to the second power higher than the denominator. And so that would simplify down to just x minus 1 squared. Now because it's a square, then the absolute value doesn't really matter. That will always come out to be positive. I'm going to erase the writing in red. And so we end up with the limit as x minus 1 squared. The limit as n goes to infinity of x minus 1 squared over n plus 2. And since x is going to be a constant, it's going to be a value that we plug into this. It's a real number, I should say. And n is increasing without bound. Eventually, this is going to equal 0 for any x that is a real number. And remember that the ratio test tells us that if the limit as n goes to infinity of the absolute value, the n plus first term over the nth term is less than 1, then the series converges. And since this will always be less than 1 for all x values, it will converge for all x values.